this basic sheet titled Getting Started 1A, and let's examine some of these very simple problems on progressions and sequences. So the first problem is about the set of numbers 1 by b plus c, 1 by c plus a, and 1 by a plus b constituting an arithmetic progression. We then want to be able to establish that a square, b square, c squared will also constitute an AP. This is what we want to establish, right? Fairly simple. If these are an AP, it clearly means 1 by c plus a minus 1 by b plus c is 1 by a plus b minus 1 by c plus a. This is what it means, right? Which means b minus a divided by c plus a into b plus c equals c minus b divided by c plus a into a plus b. This is what it stands for, right? C plus a will get cancelled, leading us to cross multiplying. B square minus a square is c square minus b square. If b square minus a squared is c squared minus b squared, this would mean that a square, b square, c square must constitute an AP. Yes or no? Right? Shall we move to the next? Now, number 2. There are two arithmetic progressions, AP1 and AP2. And what's given is the sum of n terms of the two APs. Sum of n terms of the first AP divided by sum of n terms of the second AP. They are in the ratio 14 minus 4n to 3n plus 5. That's the ratio of their nth terms. We want to be able to find the ratio of their eighth terms. That means eighth term of the first AP divided by eighth term of the second AP is what we want to find. Clear? And now, evidently, suppose the first term of this AP is A1 and the common difference is D1. The first term of this AP is A2 and the common difference is D2. Then the ratio of the sum of their nth terms, sum of their n terms is going to be 2A1 plus n minus 1 into D1 divided by 2A2 plus n minus 1 into D2. That's the ratio of their sum of the n terms, sum of their n terms, first n terms, and that's equal to 14 minus 4n divided by 3n plus 5. Clear? Now what is it that we want to find? We want to be able to find the ratio of their eighth terms. That means the required ratio is going to be A1 plus 7D1 divided by A2 plus 7D2. That's what we are seeking to find. Yes or no? This is the ratio that we want to find. Clear? Now this you can write as 2A1 plus 14D1 divided by 2A2 plus 14D2. To bring about semblance of parity between these two expressions, I multiply by 2, 2A1 plus 14D1 by 2A2 plus 14D2. That's what we want to find. Given this, very clearly, if you chose n minus 1 equal to 14, in this, choose n minus 1 equal to 14, then this ratio will emerge, right? So choose n minus 1 equal to 14. So as to bring this ratio to light, that means n equal to 15. That means 2A1 plus 14D1 divided by 2A2 plus 14D2. N is 15. So 14 minus 60 divided by 50 divided by 50. Yes or no? Clear? So which is minus 46 by 50, which is minus 23 by 25. Clear? Number 3. AGH are the arithmetic, geometric and harmonic mean between two positive numbers A and B. A and B are known to be two positive numbers. And A is the arithmetic mean between them. A is very clearly A plus B by 2. G is the geometric mean between them, which is square root of AB. And H is the harmonic mean between them, which is 2AB by 1 by A plus B. Right? 2 divided by 1 by A plus 1 by B, which is 2AB by A plus B. That's the harmonic mean. Yes or no? We want to show that A, G and H constitute a GP. These three numbers A, G and H will form a GP series and with a common ratio less than 1. If the common ratio is less than 1, it's going to be a decreasing GP. Yes or no? So if A, G and H, so look at this. G squared, what is that? AB. Look at A into H. AB. A into H is AB. So do you realize that G squared is AH? Very clearly, A, G and H must constitute a GP series, isn't it? If G squared is A into H, then AGH must constitute a GP series. Yes or no? And G by A is geometric mean is to arithmetic mean, but if two numbers are positive, then the geometric mean is always less than or equal to the arithmetic mean, right? So this will be less than 1, which is the common ratio R. G by A would be the common ratio R, right? But G is always less than A. We've seen that before, right? Geometric mean less than arithmetic mean. So AGH not only constitute a geometric progression, but one with common ratio less than 1 and therefore a decreasing. Very clearly geometric mean less than arithmetic mean, harmonic mean less than geometric mean. So it's a decreasing GP series. It's a decreasing GP series. Clear? All's good? ABC are in AP. ABC are in AP. We want to be able to show that A squared into B plus C, B squared into C plus A, and C squared into A plus B will also be in AP. This is what we want to show. Clear? Now, see, A squared into B plus C, B squared into C plus A, and C squared into A plus B will be in AP. Would mean that this plus ABC and second term plus ABC plus second term, third term plus ABC should also be in AP. If three terms are in AP and you add the same number to all the three terms, then the corresponding sequence will also be in AP, right? These would be in AP if this plus ABC, this plus ABC and this plus ABC are in AP. Yes or no? Right? That is if and only if. IFF means if and only if, right? This would mean if and only if I take A common from this, from these terms, I get AB plus BC plus CA. I take B common from this, B into AB plus BC plus CA. And I take C common from this, C into AB plus BC plus CA. If they are in AP, these three would be in AP if this divided by any non-zero number are in AP. That means I can divide throughout by AB plus BC plus CA. When I do that, assuming AB plus BC plus CA is not 0, right? This would be true if and only if A, B, C are in AP. Yes or no? right? Now, there is a sequence whose sum up to n terms is 2n squared minus 3n is the sum up to n terms. We need to suggest the nature of this sequence whose sum up to n terms is a quadratic 2n squared minus 3n, right? Huh? Minus? Oh, okay. Sorry, I'll come back to 4. Let me finish this. I'll come back to number 4. I thought there was a 4 somewhere here which I skipped. So, don't worry. We need to examine the nature of a sequence whose sum up to n terms is 2n squared minus 3n. All right. Now, the nth term of the sequence is going to be what? Whatever be the nature of the sequence, it's going to be sum up to n terms minus sum up to n minus 1 terms would be the nth term of the sequence. Yes or no? The sum up to the nth term is going to be, take the sum all the way to n terms and remove from it the sum up to n minus 1 terms. That will give you the nth term irrespective of the nature of the sequence. This is universal, right? But what is Sn minus 1? Sn minus 1 is, as you can see, replace n by n minus 1. Yes or no? Now, Sn minus 1, again, as you can see, is 2 into n square minus n minus 1 whole square, right? So, n square will get cancelled. Minus 2n will become 2n, right? And minus 1. Yes or no? And then minus 3n. So, plus 3, minus 3. Yes or no? Do you realize that? Minus 3 into n minus 1. So, that's minus 3, isn't it? That's 4n minus 5. 4n minus 5 is the nth term of the sequence. Right? Now, let me look at the difference between consecutive terms. Let me look at the difference between consecutive terms. What, is there any problem? Made a mistake? No? So, let me look at the difference between the nth term and the n minus 1 term. How do you obtain the n minus 1 term? Replace n by n minus 1. So, the nth term very clearly is 4n minus 5 minus 4 into n minus 1 minus 5. That makes it 4. Yes or no? That makes it 4. Which means what? The difference between two successive terms is the same for all n. Whether you take third term minus second term, or fourth term minus third term, or fifth term minus fourth term, the difference prevails. And therefore, the nature of the sequence must be NAP. It must be an arithmetic progression. It must be an arithmetic progression, because difference between any two consecutive terms does not depend on where those two terms are situated in the sequence. It's the same for all locations of the consecutive terms. The sequence, therefore, is characterized by being a arithmetic progression. This is what it is. Clear? So, it's an AP series. What's the common difference of that AP series? 4. 4 is the common difference of that AP series. Clear? Of course not. Because then the difference will depend on which two consecutive terms you have taken. Isn't it? All's good? Have you attempted all these problems? Can I go ahead and solve 6 for you then? Okay. The successive terms of an AP are A1, A2, A3, etc. We want to find the sum up to 20 terms. That is A1 plus A2 plus A20. Given that A5, or rather what? A6, right? A6 plus A9 plus A12 plus A15 is 20. All right. Now, Don't deploy brute force here. See, if there is a sequence of 20 terms, imagine that there is a sequence of 20 terms. Do you realize that this is 6th term from the beginning and this is actually 6th term from the end? Because after this there are 5 more terms. So this is the 6th term from the end. So which means A6 plus A15 is the sum of 2 terms equidistant from the beginning and end. Okay. A9, this is the 9th term from the beginning. After A12 there are 8 terms. So this will be 9th term from the end. So sum of 2 terms equidistant from the beginning and end will be the same. That will be equal to A9 plus A12. Sum of any 2 terms in an AP equidistant from the beginning and end is the same. Do you understand that? The 6th term from the beginning plus the 6th term from the end. 9th term from the beginning and the 9th term from the end, they will add up to the same number, right? That means this is like twice A6 plus A15. Yes or no? Because A9 plus A12 is also A6 plus A15. So that's equal to 20, which would mean A6 plus A15 equal to 10. And this is not just true for the 6th term from the beginning and the 6th term from the end. This is true for any 2 terms equidistant from the beginning and end. Now, sum up to n terms is what? A1 plus A20 into n by 2, isn't it? Isn't it? A1 first term plus last term into n by 2. But A1 plus A20 are first term from the beginning and first term from the end, which will be the same as the 6th term from the beginning and the 6th term from the end. Right? And this is 10. And n is 20 here. So 10, that makes it 100. That makes it 100. Got me? Right, Rahul? Got it? Shall I proceed? All's good so far? Now number 7. A1, A2, A3, AN constitute an AP in which each term is non-zero. We want to be able to establish 1 by A1, A2 plus 1 by A2, A3 1 by AN minus 1 AN equals n minus 1 by A1 AN. N minus 1 by A1 AN, that's what we want to establish. Just look at the left hand side. Do you realize if it's an AP, it means A2 minus A1 must be the same as A3 minus A2, must be the same as AN minus A, N minus 1, and each of these will be equal to the common difference D of the AP. This is what it means. Now look at this. Left hand side. 1 by D, right, is going to be D by A1 A2 plus D by A2 A3 D by AN minus 1 AN. This is what it stands for. Now this D I want to write as A2 minus A1. This D I want to write as A3 minus A2. This D I want to write as AN minus 1. How about this? Now what transpires is something interesting. 1 by D. If I divide, this will give me 1 by A1 minus 1 by A2, isn't it? A2 by A1, A2 is 1 by A1 minus 1 by A2. Plus 1 by A2 minus 1 by A3. Similarly, 1 by A3 minus 1 by A4. Going this way. 1 by AN minus 1 minus 1 by AN. Yes or no? And there are these many parentheses and terms will get cancelled. Do you see that? This term will get cancelled with this. This will get cancelled with this. This would have got cancelled there, right? Each term would get cancelled with the first term of the next bracket, right? So this would have got cancelled with this. There will be two virgin terms here, 1 by A1 and 1 by AN would be terms that will remain unattended, right? So this would be like 1 by D, 1 by A1 minus 1 by AN. Hey, by the way, this kind of a summation, you know, in which successive cancellation takes place is called a telescopic summation. It's called a telescopic summation. You remember we encountered that in summing up sine A plus D, sine A plus 2D, etc. We encountered a telescopic summation. We could express it as a difference in which terms could get cancelled successively. This also is another illustration of a telescopic sum, right? 1 by D into 1. Now, this I can write as 1 by D AN minus A1 divided by A1 AN. But AN is A1 plus N minus 1 into D, right? AN is A1 plus N minus 1 into D, isn't it? AN is A1 plus N minus 1 into D, and therefore AN minus A1 could be written as N minus 1 into D. AN minus A1 could be written as N minus 1 into D. The D in the numerator and that in the denominator would take care of each other. Which is what leads to the right hand side, right? Number 8 of the sheet. The interior angles of a polygon are in AP. The smallest angle is 120 degrees. And the common difference is 5, right? If these are in AP, then exterior angles will also be in AP, right? And if interior angles increase by 5 degrees, then exterior angles will decrease by 5 degrees. So if this is 60 degrees, this would be 55 degrees. Yes or no? This will be 50 degrees and so on and so forth. So exterior angles will also be in AP, but common difference minus 5. Common difference minus 5, right? Now, n sides means n exterior angles. And what is the sum of all exterior angles of a triangle? 360 degrees, yeah. Sum of all, and why so? Why so? Why is sum of all exterior angles equal to 360 degrees? Okay, tell me this. It need not be a regular polygon. It could be a tremendously irregular polygon, right? I claim does not matter this angle plus this angle plus this angle plus this angle plus this angle, no matter what, plus this angle will always add up to 360 degrees for all kinds of polygons, regular, irregular, or tremendously irregular. Now think of it like this. Think of a drunkard starting from the point A and heading towards B. Or rather, yeah, okay, heading towards B. All right. Now, he's drunk, and therefore, and he's actually supposed to move along the sides of the polygon, right? But he's drunk. At B, he doesn't take cognizance of that. He would want to move in this direction, so somebody gives him a hard kick here. And he rotates by this angle, and he starts to move along BC. All right. And then he would be tempted to move straight, but he gets another kick here, and he rotates by an angle theta 2, and he starts to move along CD. And then theta 3, and then theta 4, and then theta 5, and then say theta 6. And then after he has rotated theta 6, he would be in the same direction, say theta 6 and say theta 7. He would be in the same direction as the original direction, yes or no? That means theta 1 plus theta 2 plus theta 3 plus theta 4 plus theta 5 plus theta 6 plus theta 7 all put together eventually put him in the same direction one more time. That means all these angles must have added up to 360 degrees, isn't it? That's why he's moving along the same direction. So sum of all exterior angles of a polygon, regular or not, will always be 360 degrees. Yes or no? Isn't it? Because all these rotations have put together in a composite manner, put him along the same track AB as his original direction, right? So 60 degrees, 55 degrees, 50 degrees, etc. is an arithmetic progression with first term 60, common difference -5, number of terms n. Sum of all the n terms, which is the n exterior angles, would be n by 2 into 2a, which is 120, plus n minus 1 into d, which is -5, right? D is -5, and that must be equal to 360 degrees. And you can solve for n. You'll get a quadratic in n. And have you obtained the value of n? How much is it? 16 and 9. Yes, it can't be 16 and 9. Both. One of the values must have been negative. No? N is 9 and 16? Okay. Okay, so if n is 9 and 16, then one of them would have to be rejected, isn't it? One of them would have to be rejected. How do you do that? Yes, terms will become negative, angles will become negative. The polygon will start moving in the opposite direction, right? So, after the ninth term, say for example, what is the ninth term of this AP? 60 plus 8 into -5. Isn't it? This is the ninth term, which is -40, that is 20. Right? What is the 16th term? 16th term is 60 plus 15 into -5, which turns out to be negative. Which turns out to be negative, right? So the 16th term turns out to be negative 60 minus 75. That means if it had 16 exterior angles, then the 16th angle would have been negative, which is not the case. Right? So n equal to 16 is rejected, and therefore must be 9. On solving this quadratic, you folks seem to have got 9 and 16. 16 would have to be rejected on these grounds, because the 16th angle, the 16th term of that AP turns out to be negative. Right? Okay. So I'm not solving that quadratic. I'm assuming you'll be able to do that independently. Number 9. Okay. Here we have an AP with some terms, and I claim that there cannot be a term which is root 2, there cannot, and a term root 3 somewhere, and a term root 5 somewhere. There does not exist an AP with 3 terms along the AP being root 2, root 3 and root 5. Such an AP does not prevail. Now, what we could do is, let's assume that it does. Let's assume that such an AP does exist, right? And see, it's your choice. You can call any term the first term of the AP, right? You can start by examining that AP from root 2 onwards, right? So let's say root 2 is looked upon as the first term. Subsequently, this becomes some pth term, and this becomes some qth term of the AP with common difference d, isn't it? You could start looking at the AP from any term onwards, right? There is no loss of generality when you do that. You know what I'm saying? Okay. Now, if this be the case, then the pth term is root 3, which would be first term, which is root 2, plus p minus 1 into d. Yes or no? Obviously, pth term has to be a whole number.
Yes, means here it will not be a whole number.
It has to be a whole number. Yeah, it will out of contradiction. It might turn out. Let's see in any case. The qth term, root 5, is a plus q minus 1 into d. Yes or no? Now, if I do this minus this, then I get, or rather, I do this. Root 3 minus root 2 is p minus 1 into d, and root 5 minus root 2 is q minus 1 into d, right? And then I divide. So when I divide p minus 1 by q minus 1, p minus 1 by q minus 1, that turns out to be root 3 minus root 2 divided by root 5 minus root 2. P and q are integers. So this is a ratio of 2 integers. This therefore has to be a rational number. Left hand side has to be rational, but right hand side is very clearly irrational. So rational equal to irrational is a tremendously irrational proposition. Does not happen, right? You cannot have rational equal to an irrational. That can happen either when you have made an algebraic goof up, or there is a fundamental mistake with your original assumption. We haven't made an algebraic goof up, therefore there must be a problem with our original assumption, the assumption that such an AP does exist. That's what led to such a bizarre outcome, right? So we cannot have an AP in which there is some term which is root 2, some term which is root 3, and some term which is root 5. That's not possible. Clear? It's given that A, B, C are in HP. We want to show that B plus C by A, C plus A by B, and A plus B by C must be in AP. This is what we want to show. Very simple. They would be in AP if you add 1 to all of them and the resulting terms are in AP, then they would be in AP. That means if 1 plus B plus C by A, 1 plus C plus A by B, and 1 plus A plus B by C are in AP. This would happen if these are in AP, which would be true if and only if A plus B plus C by A plus B plus C by B, and A plus B plus C by C are in AP. Yes or no? A plus B plus C can get cancelled, assuming they don't add up to 0. This would be true if and only if 1 by A, 1 by B, and 1 by C are in AP. Which would be true if and only if A, B, C are in HP. Got me? If between any two numbers A and B, two arithmetic means are inserted, means A, A1, A2 and B must be in AP. This is what it means. A, A1, A2 and B must be in AP. This is what it means by inserting two arithmetic means between A and B, right? Two geometric means inserted between two numbers A and B. It means A, G1, G2 and B must be in geometric progression. And two harmonic means inserted between A and B, H1, H2, that means A, H1, H2 and B must be in harmonic progression. Right? This is given. This is given. All right. Now, we want to prove that G1, G2 by A1 plus A2 equals H1, H2 by H1 plus H2. This is what we want to establish. See, in an arithmetic progression, sum of two numbers equidistant from the beginning and end is the same. That means A1 plus A2 are two terms equidistant from the beginning and end. A and B are also two terms equidistant from the beginning and end. So A1 plus A2 must be AB, A plus B. Yes or no? Sum of two terms equidistant from the beginning and end is the same. Right? In a GP, product of two terms equidistant from the beginning and end is the same. That means G1, G2 must be AB. AB. Now, if A, H1, H2 and B are in HP, it means their reciprocals must be in AP. It means 1 by A, 1 by H1, 1 by H2 and B, 1 by B, that must be in AP. Yes or no? Now if these are in AP, then sum of two terms equidistant from the beginning and end must be the same. That means 1 by H1 plus 1 by H2 must be 1 by A plus 1 by B, right? Which is like A plus B by AB. But what is A plus B? A1 plus A2. What is AB? A1, G1, G2. And what is this? H1 plus H2 by H1, H2. H2 turns out to be A1 plus A2 by G1, G2. See, that's what. A1 plus A2 by G1, G2 is H1 plus H2 by H1, H2, which is what we set out to prove. Yes or no? Right? So, let's say there is an AP, etc. There is 2n minus 1 terms, then 2n terms, 2n plus 1 terms, 3n terms, right? I'm talking of problem number 12. 3n terms. We want to show that the sum of the latter half of the first 2n terms, these are the first 2n terms, that means the last sum of the last n terms, sum of the last n terms is the latter half of 2n terms. Sum of the last n terms of this is 1/3 the sum of the first 3n terms is 1/3 the sum of the first 3n terms. That's what we want to show, right? Okay. Now the last 2n terms, the last n terms of the first 2n terms will start with n plus 1, a n plus 2, a 2n. Yes or no? These are the last n terms. These are the last n terms, right? Yes or no? Where a n plus 1 is what? A plus nd, right? 2nth term is what? A plus 2n minus 1 into d. And the sum of the last n terms of these first 2n terms would be first term plus last term into n by 2. Into n by 2, isn't it? Sum of n terms of NAP is n by 2 into first term plus last term. So the sum of the last n terms of the first 2n terms is going to be n by 2 into this plus this, which is 2a plus 3n minus 1 into d. Yes or no? Clear? Which is 1/3 of 3n by 2 into 2a plus 3n minus 1 into d. What is this? Sum of the first 3n terms. This is the sum of the first 3n terms, isn't it? So this is 1/3 the sum of the first 3n terms. This is not the first sum of first n terms. This is the sum of the second set of n terms. Second set of n terms. an plus 1, an plus 2, a to n. The sum. Clear? Right? S2n minus Sn. You could have done that. All's good? Let's look at 15 together. Let's look at 15 together. ABC, RN, GP. And log of 5c by a, log of 3b by 5c, and log of a by 3b, right? 5c by a, 3b by 5c, and a by 3b are in AP. We want to show that you cannot create a triangle whose sides are A units, B units, and C units. A triangle with sides A, B, and C cannot be constructed given these conditions. All right. Now, if they are in AP, it means what? Twice this must be this plus this. This is what it means, right? That means twice log 3b by 5c must be equal to log 5c by a. Now this plus this means log a plus log b is log ab. So 5c by a into a by 3b. Yes or no? Clear? This would mean this 2 will find a place here, right? So this gives me like a 9b squared by 25c squared equals 5c by 3b. Right? Yes or no? This would mean 27b cubed is 125c cubed. Extract the cube root. Extract the cube root. So 3b is 5c. So far so good? 3b is 5c. Now, A, B, C are in GP. Can I just remove the clutter from here? Can I just remove the clutter from here? Right? B square is AC. B square is AC. Right? So I already have B and C, let's say, equal to some k. So I know B is k by 3 and C is k by 5, I already know. So B is like k by 3 and C is like k by 5. I want to write all sides in terms of a common entity k. This is what I want to be able to do, right? So I can find A from this. A then is B square by C. Yes or no? A then is B square by C. What is B squared? K square by 9 divided by C, which is k by 5, which is 5k by 9. 5k by 9, yes or no? So the three sides of the triangle, if at all, would be like k by 3, k by 5, and 5k by 9. Yes or no? All that you need to check is the sum of any two sides is greater than the third. It'll fail that test. Check for yourself. Check for yourself sum of which two sides is not greater than the third. If you find a pair of sides here such that their sum is less than the third, then obviously you cannot constitute a triangle out of it. Yes or no? You'll be able to check on that, right? Has someone already done so? Very close. What you could do is, multiply by 45 throughout, so that you have the denominators, or you can just make the denominator 45 for all of this and check with the numerators. That'll be an easier check to perform. All right. S, which is 4 plus 9 plus 20 plus 37 plus 60 plus up to n terms. Maybe this sequence still doesn't fall within the jurisdiction of things that you may have seen. Some of you may have already known about it, but check this. The difference from here to here is 5. The difference from here to here is 11. From here to here, 17, 23, 29, etc. The differences are in arithmetic progression. Do you see that? The difference between consecutive terms constitute an AP with common difference 6. Do you realize that? So what you would have to do is, you would have to devise a way to expose these numbers, because you'll be more comfortable dealing with these numbers and adding if required, right? Because they are an AP. So you would have to devise a way to get these numbers exposed and unleashed, right? What you do is, S is 4 plus 9 plus 20 plus 37 plus 60 plus the n minus 1 term plus the nth term, right? Essentially, right now you are stuck because you cannot generalize the nth term. That's your issue. So if you had a rule which told you the nth term in terms of n, then you would have a direction to pursue, right? But the first things that we need to take care of is exposing these numbers out of this. How do I expose these numbers? I write S by shifting the entire sequence 1 unit to the right. By shifting the entire sequence 1 unit to the right. That means I have 4 plus 9 plus 20 plus 27 plus minus 2 plus Tn minus 1 plus Tn. Shift the whole unit 1 unit to the right. Okay? And then subtract and subtract. For the time being, S will go into oblivion, but maybe we'll have a way to find the nth term of the sequence in terms of n. A generalization then would seem a possibility. 0. When I subtract, this is 0 equals. See, up to this, there are n pairs. This. There would be n pairs, yes or no? Right? So 4 plus, see now, the subtraction would reveal these numbers. 5 plus 11 plus 17 plus etc. How many such terms? N such terms. And then minus Tn, which goes out of picture. Yes or no? 4, 5, 11, 17, 23, and this, whatever it is. Up to this, there are n terms, minus Tn. This is what happens, right? Now, this guy looks like an odd man out here, right? Isn't it? This fellow doesn't seem to belong to this family. So now, isolate him, cut him out for a while with due apologies. Then you have n minus 1 terms to be summed up. Because this is a regulation arithmetic progression with first term 5. Number of terms n minus 1, right? Because I have isolated 4. And common difference 6. Right? This is 4 plus number of terms n minus 1 by 2 into 2a, which is 10 plus n minus 2 into common difference 6. Right? Minus Tn. Right? So just to simplify matters here, this would be 5, this will be 3. Tn then transposed on this side will become available in terms of n. So 4 plus n minus 1, and this is like 3n minus 1, minus 6 plus 5, right? Tn is 3n squared minus 4n plus 5. Yes or no? 3n squared minus 3n minus n minus 4n plus 1 plus 4. 5? Right? So now I have the nth term exposed. Nth term available in terms of n. If you plug in n equal to 1, you get T1, the first term. In this expression, plug in n equal to 2, you get the second term, 9. N equal to 3, this will turn out to be 20. N equal to 4, this will turn out to be 37, and so on and so forth. Right? And in a more general sense, the rth term, replace n by r will give you the rth term. Rth term is going to be 3r squared minus 4r plus 5. That's the rth term. What we need is summation of all the TRs. We need summation of all the TRs. These are my TRs, T1, T2. R varies from 1 to n. This is the required sum S. Summation of all the TRs are equal to 1 to n, right? Which is in principle, summation of TR is this, 3R squared minus 4R plus 5 are equal to 1 to n. This is what we are seeking to find. This is 3 times property of summation, summation R squared are equal to 1 to n minus 4 times summation R are equal to 1 to n, and 5 added n times, isn't it? 5n. What is summation R squared? Sum of the squares of the first 10 natural numbers, which is n into n plus 1 into 2n plus 1 by 6. 6 minus 4 times. This is the sum of the first 10 natural numbers, 1 plus 2 plus 3 plus n. Plug in R equal to 1, 2, 3, n, which is n into n plus 1 by 2. Plus 5n, etc. Now you can simplify this. That will give you the required sum up to n terms. So this is what you do in case you find that the differences are in AP. Objective is to expose the AP. How you do that is by shifting the entire unit one member to the right and then carrying out a subtraction so that Tn becomes available. And once Tn becomes available, you can generalize, replace n by r, and then perform a summation TR to go past this. All right? Let's look at the last problem. Can I wipe this off? Yeah, please go. Can I wipe this off? All of you need to simplify this, you know. I don't have to appear for an exam, so I can leave it in this form. But, you know, you might want to just take a few more steps and, you know, put it in a more compact manner. Find 3 unequal positive integers a, b, and c. A, b, and c are integers, unequal and positive. Unequal positive integers such that 2ab form an AP and ABC constitute a GP. ABC constitute a GP. All right. Chalo, let's look at it. Now, if I say 2AB constitute an AP, does it not mean that 2A must be B plus 2? Right? And if ABC constitute a GP, what does it mean? B square must be AC. Right? There are 3 unknowns. But there are 2 equations. So what? There are 2 equations, but there is a third condition. There is a third condition which would have to make up for the lacuna created by the third equation not being there, right? Now, b square can be written as 4 into a minus 1 whole square. B is 2a minus 2. So b squared is 4 into a minus 1 whole square. That's AC, isn't it? B square, b is 2a minus 2. So 4 into a minus 1 whole square is AC. Or C is 4 by a into a squared minus 2a plus 1. C is 4 by a square minus 2a plus 1. Right? Right? Which is 4 into a minus 2 plus 1 by a. No? Which is 4 into a minus 2 plus 4 by a. Right? Now, look. C is an integer. 4 into a minus 2 is an integer. That means 4 by a must be an integer. Yes or no? 4 by a must be an integer. See? Yes?
I can understand what you mean.
Here, this step. I just replace b by 2a minus 2 in this equation. So b is 2a minus 2. So b squared is 4 into a minus 1 whole square. That's AC. C therefore is this divided by a. And I expanded this, a squared minus 2a plus 1, etc. Now, C is an integer, left hand side is an integer. And since a is an integer, a minus 2 into 4 will be an integer. So, 4 by a must be an integer, isn't it? So, if 4 by a is an integer, then the possible values of a, if a is positive, is a can be 1, 2 and 4. These are the possible values of a. Yes or no? 1, 2 and 4. These are the only possible values of a. So our processing window boils down to a being 1, 2 or 4, isn't it? 4 by a has to be an integer. So a limits itself to 3 values. 1, 2 and 4. Right? Now let me explore each one of them. Right? Say for example a is 1. Let's see if this is possible. See, if you plug in a as 1, b turns out to be 0. It's no longer a positive integer. If you plug in a equal to 1, b turns out to be 0, which is not a positive integer. So a equal to 1 is discarded. A equal to 1 is discarded. Let me look at a equal to 2. A equal to 2 will also give me b equal to 2. They'll give me b equal to 2, but it's given that they are unequal. Therefore, a equal to 2 again can be dumped, isn't it? Because it's given that they are unequal. And if you plug in a equal to 2, 4 minus 2, 2, b turns out to be 2, which is not possible because a and b are known to be unequal. Right? So this is ruled out, a equal to 2. So then, if at all a equal to 4 should offer to me the right solution. So if I plug in a equal to 4, 8 minus 2, b is 6. Right? And c turns out to be b squared 36 by 4, 9. C turns out to be 9. So the numbers are 4, 6 and 9. These are the numbers. 4, 6 and 9 are the numbers. Yes or no?